Okay, as we discussed in the last class, where I picked up some questions, fundamental questions on the basis of previous discussions. In first few questions discussed in the last class on the basis of the earlier sessions, and in continuation with that set of questions, today we are going to start from that exactly. So up to question number 3, it was discussed, and you look at the screen. Sub question 5 of question number 3. It's a very, yeah, I think 4 also it was left. Sub question 4, you can see x such that x is a prime number which is divisor of 60. Divisor of 60. So you can write the prime factors of 60 within second bracket. Next, the set of all letters in the word trigonometry. So here all the alphabets here just to write using comma within second bracket, because basically we should have the set in roster form, that is tabular form. So just letters we have to write from the word within second bracket using comma. If any particular letter is repeated in the word, then it is not mentioned repeatedly within the bracket. Here you see two O's are there, T, two T's are there. So only one T you can write. You are allowed to write only one T within second bracket to say set. So if any letter is repeated, you have to write once only within second bracket. And obviously, usage of comma is compulsory. Very simple. The set of all letters in the word better, same thing. Let's go to the question number 4. Write the following sets in set builder form. It's just reversed. Now here in this example, few sets are given in tabular form or roster form. Now we have to express these sets in set builder form. That means in which form the sets were given in question number 3. All the examples of sets given in the question number 3 are in the form of set builder form, and sets given in question number 4 are in roster form. So these sets of 4 we have to express in set builder form, that is like the sets given in question number 3. So set builder form already we have discussed how to write a set builder form. The structure is here available in the screen in question number 3. These are the structure of the set builder form. X such that X is to write here. What about X? Characteristics of the elements we have to define after such that colon symbol. So after colon sign we have to write about X, because the first X represents all the elements. So about the elements, the characteristics we have to mention after such that. That is definition on element, which are definitely must be well defined, otherwise elements will not be possible to have from the definition. So well defined must be well defined, whatever we write after such that. So that's the structure of set builder. In question number 4, sub question 1, 3, 6, 9, 12. 3, 6, 9, 12. Here misprinting is here. The first bracket is used just before 3. It is misprint actually. So 3, 6, 9, 12. We have to write in set builder form. You can write on your page. Try to write the set builder form of this 3, 6, 9, 12. Before going to write the set builder form of a set, we have to observe very carefully the elements behavior. What kind of elements are there? What particular behavior or pattern or some numerical properties are maintained in the sequence of the elements. If you observe carefully here, you will see 3, 6, 9, 12. So we can observe this. These are actually multiples of 3. 3 into 1, 3, first element. 3 into 2, 6, that is second element. 3 into 3, the third element. 3 into 4, 12, that is fourth element. So these are actually, if we observe carefully, then we can get it. So here we have found, observing the elements are multiples of 3. Only 4 multiples are here. First 4 multiples of 3. So 3 into 1, 3 into 2, 3 into 3, 3 into 4. So multiples of first 4 multiples of 3 is here. So that is the main characteristic of the element. So you can write now its set builder form. So it would be x such that after colon you can write in literature form also, x is the first 4 multiples of 3. X is the first 4 multiples of 3. That's all. The set builder form. Or otherwise you can write x is equal to otherwise you can write x such that after colon you can write x is equal to 3 into n. 3 into n. X is equal to 3 into n. So basically multiples of 3 we write 3 times of something. So you can write x is equal to 3 into n. Now what is n? You have to write again using comma. So comma n is equal to 1, 2, 3, 4. N is equal to 1, 2, 3, 4. So this is alternative expression in set builder form. X such that x is equal to thrice n, comma n is equal to 1, 2, 3, 4. Second one, if you see, subquestion 2 of 4. 2, 4, 8, 16, 32. 2, 4, 8, 16, 32. Now, if you observe the behavior of these elements, you will find these are first one 2 to the power 1. We can regard this as 2 to the power 1. Next one is 4. We can think it as 2 to the power 2. And third one we can anticipate as 2 to the power 3. And the fourth one, that is 16, we can anticipate as 2 to the power 4. And 32, which is 2 to the power 5. So that is the special character maintained in these elements. So elements structure is actually 2 to the power 1, 2 to the power 2, 2 to the power 3, 2 to the power 4, 2 to the power 5. That is the power of 2 is increasing and which is up to 2 to the power 5. That is from 2 to the power 1 to 2 to the power 5. So this special character of the elements we just have to mention in set builder. So its form is x such that x is equal to 2 to the power n. X such that x is equal to 2 to the power n, comma, what is n? N is equal to 1, 2, 3, 4, 5. X such that x is equal to 2 to the power n, comma, n is equal to 1, 2, 3, 4, 5. So that's all about its set builder form. Number 3, if you observe 5, comma 25, comma 125, comma 625. Here also we can observe easily. First one is 5 to the power 1. Second one can be written as 5 square. Third one 125 can be written as 5 to the power 3. And 625, fourth one can be written as 5 to the power 4. So that is the characteristics of the elements. So 5 to the power 1, 5 to the power 2, 5 to the power 3 and 5 to the power 4. So you can write set builder form x such that x is equal to 5 to the power n, x is equal to 5 to the power n, comma n is equal to 1, 2, 3, 4. N is equal to 1, 2, 3, 4. That means when we put the values of n, then we have exactly these elements. X, I repeat it, x such that x to the power n, sorry, not x, 5 to the power, sorry, x such that x is equal to 5 to the power n, comma, n is equal to 1, 2, 3, 4. 5 to the power n. N is 1, 2, 3, 4. Sub question 4 in 4. 2, 4, 6, it's very simple. Even numbers. All even numbers are here, or multiples of 2 you can write. So x such that x is equal to twice n, comma, n belongs to capital N. That is n is natural number. X such that x is equal to twice n, because all are even number, multiples of 2, all multiples of 2 are here, even number. So x is equal to twice n, comma, it is up to infinity and dot dot is there, 2, 4, 6, 8, 10, 12, 14, it's going on up to infinity. So the value of n you cannot write in terms of the number, actually just n must be infinite. So all natural numbers are there. So you cannot write exactly like the previous examples, n is equal to something finitely you cannot write. So simply x is equal to twice n, comma, n belongs to capital N. That is for all natural numbers. And similarly, number 5, 1, 4, 9, 100, up to 100. If we observe the characteristics of these elements, you can find it. So I am giving you 1 minute. Write yourself. Can you say anybody if you have written? If somebody has written, can you respond? Have you written anybody? Anybody? Can you say? No. Okay, then you can note it down. 1, 4, 3, 9, and so on up to 100. If you observe the behavior of the elements, then you will find 1 is 1 square, 4 is 2 square, 9 is 3 square. So 1 square, 2 square, 3 square, 4 square, 5 square. It is like this. And dot dot up to 100. 100 means 10 square. So that means 1 square, 2 square, 3 square, 4 square up to 10 square. So that is the main characteristics of the elements. So to write in set builder form, you can write x such that x is equal to n square. N square, where n comma n is equal to 1 comma 2 comma 3 dot 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 up to 10. X such that x is equal to n square, comma n is, or you can write n is natural number less than 10, less than or equal 10. N square x such that x is equal to n square, comma n is natural numbers less than 11, that is up to 10. That means less than 11, n is natural number less than 11, that is up to 10. Okay, so this the way to write the set builder form. Here in question number 4, the sets were given in tabular form or set builder form, and we have written in set builder form. Number 5, list all the elements of the following sets. List means actually we have to write the elements, so definitely it is again in tabular form or roster form. We have to express the elements, list all the elements. So within second bracket we have to write the elements using comma, that is in roster form. Simply you can think as roster form. So here again in set builder form examples are given here. So number 5, sub question 1, a name of the set A is equal to x such that x is an odd natural number. X such that x is an odd natural number. That means it's just a collection of odd natural numbers. Collection of all odd natural numbers. So if we would like to list the elements within second bracket, just you can write the odd natural numbers using comma. So since it is infinite up to infinity, so we cannot write all the odd natural numbers within second bracket. So just after writing 3, you just use dot dot. 3 dots are required to represent up to infinity. So x is an odd natural number. That means within second bracket we have to write 1, comma 3, comma 5, comma dot dot dot. That is up to infinity. All natural odd numbers. Look at next example B. B x such that x is an integer, comma, what is the integer? Integers are like this: greater than minus half, greater than minus half, and must be less than 9 by 2. So greater than minus half, that is minus 0.5. So immediate next integer will be after minus 0.5, and greater than minus 0.5, immediate integer is 0. So integers will be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, like this. These are integers. But upper limit is there. It must be, the integer must be less than 9 by 2. 9 by 2 means 4.5. So 9 by 2 means 4.5. That means the integer must be less than 4.5. So integer less than 4.5. So immediate less than 4.5 is 4. So the limitation of x is x must be, first one integer, second one must be greater than minus 0.5 and must be less than 4.5. So since it is less than 4.5, so the limit will be up to 4, and lower limit is minus 0.5. So immediate greater than minus 0.5 integer is 0. So ultimately the integers are 0, 1, 2, 3, 4. X such that x is an integer minus half less than x less than 9 by 2. Its elements will be, within second bracket you must write 0, comma 1, comma 2, comma 3, comma 4. 5 we cannot include here because the integers here must be less than 9 by 2. That means must be less than 4.5. And in the third one, see, x such that x is an integer. X is an integer. Integer, to be fulfill the condition, x square must be less than and equal 4. X square must be less than equal 4. So if we put x equal to 0, so 0 square obviously less than 4, so 0 will be one element. If we put 1 square, it is also less than equal 4, so 1 also an element. If we put 2 square, 2 square means 4, equal sign is there, less than and equal, so 2 is also element. So we have got positive elements 0, 2, 0, 1 and 2. 3 elements we have got. Again, if we put minus 1 here in place of x, because minus 1, minus 2, minus 3, these are also integers, negative integers. So it is allowed to consider. If we put minus 1, then minus 1 square is also 1 and which is less than 4. So minus 1 is also an element here. If we put minus 2 again, minus 2 whole square means again 4. It is less than equal sign is there. So minus 2 is also an element of this set. So we have got elements minus 2, minus 1, 0, 1, 2. Minus 2, minus 1, 0, 1, 2. 5 elements. These 5 elements will be there in this set. We cannot put 3 because 3 square means 9 and 9 is not less than 4. We cannot put minus 3 because minus 3 whole square means again 9, and 9 is not less than 4. So the elements to be listed here in C, it would be minus 2, comma, minus 1, comma, 0, comma, 1, comma, 2, and must be within second bracket. So that is the in roster form. Here it is not mentioned in roster form. List all the elements. So it's same thing. And few are left. X is a letter in the word Lowell. Just letters you have to write within second bracket. It's very simple. X is a month of the year, not having 31 days. It's very simple. You can just write the names of the month within second bracket. So that is the answer. So this is the way to convert from roster to set builder and set builder to roster. It's a very important as a basic concept of set, and it is just matching. Very simple. Okay, next some types of sets will be having. Different types of sets are there. We know up till now the definition of sets and examples. A symbol to represent belongingness, it is epsilon, and representation of sets, and which were roster form or tabular form, and set builder form. So up till now we have discussed this much. Now I do hope you have understood about the definition of sets, and how to write a set, how to represent a set, and how to write when a particular element lies in a set using the symbol epsilon. Symbolically, how we can write some element belongs to a particular set. And we have learned about representation of sets, which are two forms. First one is roster or tabular, and second one is set builder. And through some basic examples, we have learned this also, how to convert a set from roster to set builder, and conversely from roster to set builder, and conversely from set builder to roster. So this transformation also we are familiar in sets, and this is about the fundamentally uh, what is set and how to write. Some types are there. There are some types of sets which are basically classified with based on the number of elements, and that types are, first one is given, it is empty set. First one is here, it is given empty set, and it is sometimes known as void set, and sometimes known as null set. So null set, void set, empty set, all are same. So when we say a set is empty set or null set or void set, so literally you can understand what empty means. So that's exactly. So when you define properly a set, you are able to define the elements of a set, but if you go to pick up the elements on the basis of that definition, you do not find any elements. You have defined properly, but elements does not exist. In definition, you do not have any mistake. You have not committed any mistake in the definition of the set, but elements does not exist. Then also it is set, and which is empty set. That means when a set has no element, a set having no elements is called empty set. So you may raise question, without elements, how can you say it's a set? Because there is no element. But as per the definition of set, in the definition, there is nothing is mentioned on the number of elements. Regarding the number of elements, nothing is there in the definition. So in the definition is simply collection of well-defined objects. Well-defined objects. If you define properly, in your definition, do not have any mistake, and since it is well-defined, we have defined properly, and we do not have any problem also to pick up the elements. So definitely it is set. But elements does not exist, so number of elements become 0. So then it is empty set or null set. So some examples you can pick up here. In this example, you can observe here B in the screen. Here an example is given. X such that X is a student presently studying in both class 10 and 11. In this example, if you observe, clearly define what type of students are there in the set B. It may be possible, it may be impossible, that is different thing. But in the definition, nothing goes wrong. X is a student, that is collection of students who are studying right now or currently in both the classes 10 and 11. So no element exists, no student exists. That is number of elements in this set is 0. So it is empty. If I say collection of the natural numbers between 0 and 1 or 1 and 2 or 2 and 3, whatever. So collection of natural numbers x such that x is natural numbers between 0 and 1. So here definition is very clear. But when we go to pick up the elements, that is when we go to pick up the natural numbers between 0 and 1, we do not get anything. That is, no natural number exists between 0 and 1. So number of elements is 0. But definition is correct. So it is set. So that's why some situations are there, some collections are there where definition is done properly, well defined, that means, but elements does not exist. These types of situations definitely we can avoid from the sets, and these are called empty set, null set, or void set. Simply a set having no element. A set having no element is called empty set. So that is the simple definition of empty set. null set or void set. Okay. Next type will be finite set and infinite sets. So its time is likely to be over. So that's all for today. Thank you so much for joining, and I do hope you will give few minutes more. You will invest few minutes more every day immediately after the session, so that you can perceptualize very comfortably, and you can go through any books or any internet searching related to the topic discussed here very comfortably. So thank you so much.